We're here outside the journalism building, one of the oldest buildings on campus. In fact, it was moved brick by brick from downtown Baton Rouge in the 1920s. Even though we have lots of old buildings here on campus, we also have a lot of new and exciting departments. Some of the most exciting work is being done in the Department of Physics and Astronomy. Dr. Joel Tohline will talk to you about some of the work that he's doing in visualizing neutron stars with scientific visualization tools.
The simulation I'm going to show you here is a much more classical system of two stars interacting where the relativistic effects are not very important. Nevertheless, there's some very interesting dynamical effects that one can observe that are astrophysically important. In particular, what I'm going to show is this screen is really split into two pieces. On the left-hand side, you're looking down on the orbital plane of two stars in orbit about one another. And so you're looking down on that plane and seeing how the tidal interactions are able to strip fluid from one of the stars, and it then lands in a supersonic fashion on the companion star. Now, most of the movie we're going to show you is from what we call a rotating frame of reference. That is, you're not actually going to see the orbit, but we're jumping into a frame where you're viewing the system as though you're riding along with it. And so we've taken out that overall orbital motion, and any relative motion is what's important when you look at it. So on the right-hand side of the movie, we show a magnified view of the central regions of the two stars where the interaction is strongest. And so you're going to see the same evolution, but this is the magnified central regions, and this gives you a more global view. And the upper right-hand corner is counting off the number of orbits that the system has gone through. So we've gone through just a couple of orbits here, and you begin to see a little bit of gas streaming off the back end of this star. And this star is donating material to its companion, so we call it the donor and the accretor. You can see this nice mass stream forms, and so material from this star is being added to that star over time. And for a brief period here, we're actually jumping into a frame that lets you see the overall orbital action, but then we'll jump back into the rotating frame so that you'll focus in on the mass stream. Now the stream, as it hits the companion star, as I said, actually hits the star supersonically. It's about 25 times the speed of sound, or a Mach 25 impact. So a shock front forms here, much as forms in aerodynamics when an airplane exceeds the speed of sound. But the stream hits not perpendicular to the surface, but at an oblique angle, and therefore is also spinning up the companion star. So it's not only dumping material on, but adding spin to that star. And the companion star then is responding to that. And keep in mind, these are just two big balls of fluid that we're following with the appropriate mathematical description. And the interaction here is actually kicking up waves, or sloshing waves on the surface of the companion, and exciting sort of natural modes of oscillation in that star. And you can see that it sometimes looks like a square, sometimes looks more pentagonal, and other times more triangular. And this then gives us an indication of what goes on in astrophysical systems when you get two stars interacting in this way, that the companion star can really be excited to undergo some interesting dynamics. And one of the most interesting things that can happen is the companion can actually undergo a violent collapse as a result of having too much material added to it, and then in response will sometimes explode in a supernova explosion. Here at the end, I've simply stopped the simulation after 31 orbits and are flying around the full three-dimensional configuration to give you an idea of how complex the structure is. And we're artificially letting you see the interiors of both stars, while showing in sort of the blue translucent surface some of the structure of what's happened as that companion star has been sped up. And this is actually one aspect that's easy to sort of involve undergraduate students from other disciplines, that without knowing anything about the underlying physics or astronomy, they can get very interested in the visualization. The tools that are used for the visualization here are the same tools that are used by Disney and Pixar, for example, in building three-dimensional objects for movie presentation. So it was actually an undergraduate student that put together this final sequence of flying around the object and letting you look at it in detail.